In this video, we're going to be looking at the properties of algebra, and you should get some note cards or use your notebook because you will need to write these properties down and know this vocabulary as we will be using it throughout the entire course. So we are going to get started with one that should be very familiar to you. It is the distributive property. And the distributive property is best described as multiplication over addition or subtraction. And here are some examples, and I'm going to try to give examples and non-examples as we go through all of these properties. So here are some examples of the distributive property. Remember, multiplication over addition or subtraction. And lots of times you've seen your teachers just use these arrows. So basically what's happening here is this is 3 times the quantity of a plus 2. So it's not just 3 times a, it's not just 3 times 2, it's 3 times a plus 2, which is why we have to triple both parts of the expression that's inside of the parentheses. So let's distribute. 3 times a is 3a. Plus, the plus is not changing. Remember, it's multiplication over addition or subtraction. 3 times 2 plus 6. So we are not able to solve this as this is simply an expression. Remember, an expression does not have a verb. This is 3 times a plus 2. There's no is, was, will be, is going to be equal to. So we're just simplifying using the distributive property here. Next, we have a negative 10x up front. And the negative 10x is what's being distributed to the quantity 3x minus 4. So we're going to be multiplying over addition or subtraction. So remember, pay attention to the signs here. These signs are going to change because we're multiplying by a negative out front. Negative 10 times positive 3 is negative 30. Remember, this is x to the first times x to the first. So in pre-algebra, you learned the properties of exponents. If we're multiplying and the bases are the same, add the exponents. X to the first times x to the first is x squared. Because truly, x is getting multiplied to itself twice. Next, multiplication over addition, or in this case, subtraction. Now we have a negative 10 times a negative 4. A negative 10 times a negative 4 is a positive 40. And then we have 1 power of x that gets multiplied through as well. This is our simplified expression. Next, we have t squared. T squared is being multiplied through. The quantity this time has 1, 2, 3 terms. So we're going to multiply once, twice, 3 times. So we will end up with a 3-term expression as our simplified answer. Remember, there's a 1 in front of this t squared. So when we multiply, we're going to multiply as if we're just multiplying by positive 1 first. 1 times negative 3 is negative 3. T squared times t to the first, 2 plus 1 is 3. T to the third power. These are like bases. That's why we're adding the exponents. Next, 1 times 1 is still 1. You do not have to write the 1. You can write the 1 if you want, but it's not necessary. Next, we have t squared times u. Normally, it's just good algebra manners to put your variables in alphabetical order. So t squared times u. Next, 1 times negative 7 is negative 7. T squared times v is t squared v. That's using the distributive property. The distributive property is multiplication over addition or subtraction. So last thing I have on the paper today is a non-example. And this is a non-example because this is just straight multiplication. This quantity inside the parentheses is multiplication. So there's no distributing the 5 here. In this case, we would just follow the order of operations, which would tell us to do what's inside the parentheses first. 4 times 3s is 12s, and 5 times 12s is 60s. So examples, non-example. No need to write down a non-example, but I do want to bring them to your attention so you can see the difference. Next, we've got another one that you should be familiar with. It's the commutative property. And notice that I've got the letters C-O highlighted here. So the commutative property, note the spelling and the pronunciation, commutative, not communicative or communicative, but commutative. It applies to both addition and multiplication. And it allows the user to change the order. That's why I have the C and the O underlined. The commutative property applies to addition and multiplication only, and it allows the user to change the order. Let's see some examples. So, obviously, 3 plus 4 plus 5 could easily be rewritten as 3 plus 5 plus 4, or 4 plus 3 plus 5. There's 6 different ways that we could arrange 3 plus 4 plus 5, and it still represents exactly the same sum. The sum will not change. It's going to be 12 no matter how we change the order. The commutative property applies here. Next, we have 10x minus 6x plus 7x. But wait, Mrs. Hendry, you said it only applies to addition and multiplication. Well, yes. Remember, we always have an option of rewriting subtraction as addition, and we can do that by simply writing it as plus negative 6. Addition of the opposite allows us to change subtraction to addition. So now we can change the order. Negative 6x plus 10x plus 7x, and the sum will remain the same. So we're still changing the order here. This time it's all multiplication. Remember, multiplication can be with parentheses, it can be with a dot. We normally do not use an X in Algebra 1. So we can change the order to negative 2 times 3 times 10, or 3 times negative 2 times 10. We're still going to get the same sum. This is 30 times negative 2. It's negative 60. Or this is negative 2 times 3, which is negative 6, times 10, which is still negative 60. So it doesn't matter how we change the order, the product will remain the same. So one last one that mixes addition and multiplication. So if we think about using order of operations here, this would be 9 times 5, which would be 45, which would be the same as if we flipped those parentheses. We're still going to get 5 times 9, which is 45. We could even flip them inside the parentheses. 3 plus 2 times 5 plus 4. It's still 5 times 9, which is still 45. So we can change the order using the commutative property. It applies to addition and multiplication. Next is the associative property. And an association is the same as a group. A group is a synonym for the word association. So we can change the grouping, and this applies again only to addition and multiplication. So we can change the groupings within addition or multiplication and still have the same sum or product. Here are some examples. So here we have 2 plus 7 grouped together and then adding to 10. Of course, that would be 9 plus 10, which is 19. What if we change the groupings to 2 plus 7 plus 10? According to order of operations, that would become 2 plus 17, which no matter what, they're both equal to 19. Doesn't matter how we change the grouping, what we group together, it's going to remain the same sum. Notice I did not change the order. 2 plus 7 plus 10, 2 plus 7 plus 10. The order did not change, just the groupings. We can also do it with multiplication. So right now we have 3 times 2 times negative 5. That's 6 times negative 5, which of course would be negative 30. What if we change the groupings to 3 times 2 times negative 5? Then that would be 3 times negative 10, still negative 30. The product remains the same. So order is the same, but groupings have changed. That's the associative property. Again, another reminder that a subtraction can always be changed to addition by rewriting this as plus negative 4, addition of the opposite, which would allow us to now change the groupings. So this would be 10x plus negative 4x, which would be 6x, plus x, which would be 7x if I simplify here. If I change the grouping, noting that once again this is now addition, this would be 10x plus negative 4x plus x. So this would be 10x plus negative 4x plus 1x. Remember there's a 1 in front of that x. That would be negative 3x. 10 plus negative 3 would still be 7x. The sum remains the same if I change the groupings. So the associative property applies to addition and multiplication. Properties of equality. There's a lot on this page, so let's take just a few minutes to go through it quickly. These properties allow us to keep our equations balanced. We're going to talk a whole lot more about keeping our equations balanced in the next few videos. Just remember, whatever you do to one side of the equation, you must do to the other. So here's just quick examples of that. If we have a plus 5 equals 7, we can subtract 5 from both sides and get a equals 2. That's the subtraction property of equality. If we have x minus 10 equals negative 5, we can add 10 to both sides. That's the addition property of equality. If we have r divided by 3, if I want to undo division by 3, I multiply both sides by 3. That's the multiplication property of equality. And finally, if I have negative 4 times t, if I want the t by itself, I can divide both sides by negative 4. That's using the division property of equality. So properties of equality, we're going to see more examples of that in our solving equations video. But there we got it. All the properties of algebra that we'll be using regularly in class throughout the year.